Hey everybody, in this lecture we're going to talk about the keywords overload and override, which do two different things and they're a common source of confusion with folks. So we're going to start with overloading, which is something that's going to come up quite often. And I'm just going to do a quick example over here. So this is some C# code. It would work the same in Java. You just have to change the right line to a system.out.println. So what we're doing here is I've set up two variables, an x and a y variable, and I have a method called add2, which takes in an a and a b and returns the sum of a and b. So it takes in an integer and an integer, it returns an integer, and of course it just adds the two numbers together. So if I run this, not surprisingly, passing it in 1 and 2, I get back the number 3. Life is good. None of that should be particularly confusing, hopefully. But what happens if I suddenly needed to call this over and over and over again, and one of the times that I needed to call it, all of a sudden instead of y being equal to 2, y was suddenly equal to 2.5? Well, the first thing is I can't have an integer 2.5, so I'm going to make that into a double, let's say, and I'm going to try and run this code. And this seems obvious that you would say, well, 1 plus 2.5 is 3.5, so why is this so hard? Well, C# and Java are both very, very specific when you call a method. The method has to match exactly what it is that you called. So to be clear here, what's going on this line when I call add2 is I'm passing it an integer and a double. So what the compiler is doing is it's looking for a method called add2 where the first thing is an integer and the second thing is a double. And as you can see, there currently is no such method. There's one called one called add2 that takes integer, and that's it. So if we look at the exact error message that we got from C# and Java would produce a very similar error. It says the best overloaded method match for add2 int has some invalid parameters. Argument 2, I cannot convert a double expression to an integer. So what it's saying is, you gave me a double here, and I neither know how to convert a double into an integer, because I would lose some data if I did that, nor is there a method that takes in an integer and a double. Therefore, I don't know what to do. Compilation has failed. Go sit in a corner and think about the terrible things that you have done in your life. So how would we fix this? Well, effectively what I need is, I need another method that takes in a float, or a double, as my second attribute. But as you can tell, straight away, that causes two problems. The first problem is, what about my integer adding now? It no longer works because I've changed the method. And the second problem is that valid? Can you add a double to an integer and will it return an integer? No, that's not really valid. This method would probably now need to return a double. So that's going to cause a whole new problem because then down here, I was getting my answer back into an integer, and so now that needs to be a double. Okay, so now life would pretty much work, but I've caused a whole lot of confusion, and I can no longer add two integers. So what to do? Well, the answer is I need to overload my add2 method. So what I'm going to do is I'm going to make a copy of that method, and it's still got the same name, but I'm going to give it back its original definition. It took in two integers, and it returned an integer. This was what was there when we started. And I'm going to leave in this other version, and in this case, I'm going to change it so that it takes in two doubles, let's say. So double A, double B, and down here, what I'm going to do is I'm going to change my first parameter to be a double, and now I'm going to run this code. So all of a sudden, it's able to add two doubles, because there's a method that knows how to take in two doubles. And just to prove a point, there's still the ability, I'll do int a equals 1, int b equals 2, and I will say int c equals add2 a b. I can still add two integers. So my z comes back, well, I never printed out the answer, did I? So that's not very useful. Let's do a print of the c, and we will see that c is now equal to 3, just like it used to be. So what I have done here is what's called overloading. I have overloaded a method to have two different versions that can be called. It's the same method name, it's called add2 in both cases, but the first one takes in an integer and an integer, whereas the second one takes in a double and a double. And I could have more than 2 overrides. It's perfectly plausible that I might need another version of it that takes in a double and an integer. And that would probably still return a double. And I may need another version that takes in an integer and a double. And as you can see, these are now 4 versions of the same exact method. All 4 of them take in different parameters, and they do pretty much the same thing. So this is not an uncommon situation, whereas you may need the same method to be able to work in different ways. Think of it like a chameleon. There's different versions of this same chameleon that are different colors, right? There's one that takes in 2 integers, there's one that takes in an integer and a double, there's one that takes in a double and an integer, and there's one that takes in 2 doubles. And maybe there's one that takes in a character and an integer and does something with that. I don't really know what it would do. Maybe there's one that takes in a float and a double and a double and a float and a float and an integer and a float. You could have 50 different versions of that same method, and they would be said to be overloading of the same method. So in your head, anytime you hear the word overload, you need to think of the fact that there's more than one version of the same method. To be clear, the return type is not considered part of the overload. So over here I said public static double, and this one is also a public static double. So that part does not make it an overload. It's the parameters that make it an overload. An overload will have 2 different parameters. So this will all make sense now, and in 10 seconds later in the video, you're going to go, wait, which one was which again? So let me reiterate, an overload is a method that has the same name and different parameters. That is an overload, and it is common to do it for any method, like I did here. It's common to do it in a constructor inside of a class, and we saw that in the previous videos where when you defined a class, so I'll do class A, and I'm just going to have a public class A constructor, which takes in nothing. And we need some kind of an attribute here. So I'll say private int x. And so I'm going to set x equals to 0 in my default. And then I may have another version of class A, which takes in an integer. We'll call it y. And it sets x equal to y. So again, that's an example of an overloaded, in this case, constructor, but it's an overloaded method that just happens to be a constructor. So, beating the dead horse here, overload means you have the same method name with different sets of parameters. The parameters can be different in number, which was what happened here. I had 0 parameters and then I had 1 parameter, and or they can be different types. So I could have another version of this that takes in a character, and another version of this that takes in a boolean, another version that takes in a string, another version that takes in a dog, and so on and so on and so on. As long as they are different parameters, it is said that I have overloaded the method. All right, so method overloading, same method name, multiple sets of parameters. Do not confuse overloading with overriding, which we're going to talk about here in a moment. And then the signature of each overloaded method must be unique, which means that there has to be different parameters. The signatures includes the number and type and order of the parameters. So you've seen examples of that. This was a case where the number of parameters changed. This was a case where the types of the parameters changed. And this is a case where the order of the parameters changed. B versus A versus B, and so on. The compiler determines which version is being called by matching the parameters. So that's a very important statement. If I come down here and I change one of these to a double, I'm just going to show what happens. So A is an integer and B is a double. So I need to find the one that's going to do that, and that's going to be this one. And just to prove a point, I'm going to system.out.println called me. All right, and what you're going to see is called me is going to print identifier. You know what? This is not Java. That's going to print because that's the one that actually got called. You cannot convert a type double to an int. And let's see, where am I doing a double to an int? Oh, well, it's because what's coming back from the method at this moment is a double, but I'm saying that I'm getting back an int down here, so I need to change that to a double. it's very picky about all of this. It is said that both Java and C# are what are called strongly typed languages. And what that means is when you say something is an integer, it better be an integer. If you try to say something is an integer and then you give it a floating point number, it's going to complain and say, you're doing the opposite of what you told me. And it's to try and help you because it's assumed that if you meant it to be a float, it should be a float. So make sure you're doing that. So you can see that that got called, versus none of the other ones got called. We know that because it matches it. So when you call an overloaded constructor, what's happening is you're calling the one that matches the signature of the parameters that you're passing. Likewise, if you're calling an overloaded method. Okay, and this is just another example here. You have two versions of try me. This one takes in one integer, this one takes in an integer and a float, similar to what I did. Which one is getting called? In this case, we can tell that the second one is going to get called because we passed it an integer and a float. This is very specifically a float because we put an F at the end of it. Okay, it is possible in C#, and this part of this is only valid in C#, to override the operators. So what does that even mean? And I'm just going to show you an example down at the bottom here. So let's imagine I have a class dog, and dog has a string and it has a weight, and we have our constructor for dog, and life is good. In this case, I can choose to override the plus method inside of dog. And let's look at what happened here. Again, this is a C# only thing. I'm saying public static dog operator plus takes in dog1 and dog2, and it returns a merged dog. Why on earth would we ever want to do this? Well, if you're adding two numbers, it's very obvious as to what it is that you're trying to do. You're trying to add this number and this number. But if I tell you to add two cars or add two dogs, what in the heck does that even mean? And the answer is you got to define what it means. If that's something that you want to be able to do, then that's something that you have to specify in code how that would go about working. And so in this case, a merged dog in our imaginary example is simply the sum of the two names. So we're concatenating their two names and we're adding their two weights together. This is some weird factory where we're taking dogs and merging them into one single dog. It gets really dark in these examples. I don't know why. But anyway, so we're taking the weights, we're adding them together, we're taking the names, we're adding them together, and we're returning back our combo dog, which is not rabbit and has a name that is the concatenation and whatnot. So this is overriding the plus operator, and we do that because we want to be able to add these objects. So we have to specify how that's going to work. The plus operator is not the only one you can override. In C#, you can override plus, minus, the multiply, divide, you can override equals equals. And that one makes a lot of sense for dogs. Is this dog the same as that dog? Well, maybe the way that you would check that is, do they have the same name? Do they have the same weight? And are they the same status of rabbit? And maybe that's good enough to know that they are the same dog. You can override plus plus or minus minus or any of those types of things because you might want to be able to increment a dog. I don't know what that even means in the real world, but I think you get the idea. All right, so this part of the lecture, C# is the only language of the two that we teach in this class where you can override an operator. It is also possible in C++ if you've come from that world. All right, so that's overloading operators. We're going to switch topics and we're going to talk about overriding, which is a different thing that happens. So I'm going to go ahead and I'm just going to, for equity, flip over to Java. And I'm going to create a new Java. No, I don't need to. Yeah, I do need to. All right, we're going to do a new Java method or example. And what I'm going to do is override example. Okay. All right. Every object that you create in Java inherits from an object called object. This is something we're going to talk in more detail about later on, but suffice it to say that there is this magical thing called object, and every single object in the world is a child of that parent called object. The main parent object has a method in it called toString, and what it does is it prints out some details about the object. So I'm going to make a dog.java because that's our favorite thing to do, and I'm going to in there say class dog. Yes, it's a bit unfortunate that it missed the first two letters. All right, so class dog, and we'll just say public int x, whatever. All right, so there I have a class. I'm going to go over to main, and I'm going to make me a new version of that dog. So I'm going to say dog, my dog equals new dog, and I'm going to, very oddly, print out my dog. What does that even mean? Well, let's find out. So I'm going to run that. And what I mean for it to do is I mean for it to print out the details about my dog, obviously. But Java doesn't know what a dog is, even though you gave it a class. And so what does it actually do? Well, what it did was it printed out the name of the class, and then it printed out this, what seems like a random set of numbers and characters. If you stare at them for long enough, you'll realize that this is a hexadecimal number, and hexadecimal numbers have the numbers 0 through 9, followed by A, B, C, D, E, and F. And they're a way of representing large numbers. If you were to stick that into a hexadecimal calculator, it would give you some huge integer. What is that? Well, very specifically, not that this matters in the slightest, it's the exact address in memory where the dog object is being stored, which means absolutely nothing to you, nor do you care in the slightest where the address in memory of the dog object is. So why on earth did it print that? Well, it printed it because it has no idea what you actually meant when you said print the dog. Because what does it mean to print a dog? It's obvious what it means to print the number 7, it's obvious what it means to print a string, but what does it mean to print a dog? I don't know. And the reason that Java did that is because you never told it what to do. So I'm going to go back over to my dog example, and I'm going to give the dog a name. So I'm going to say private string name, and I'm just going to make a constructor here. So I'm going to say public dog, and I'm going to take in a name string n just to make life easy. I'm going to say name equals n, and life is good. I now have a constructor that allows me to set that. So I'm going to give my dog a name at the time that I created it. So I'm going to say this is Fluffy. Good old boy Fluffy. Now, when I print it out, nothing has changed. Even though I gave the dog a name, that doesn't actually mean anything. The dog doesn't print out its name. I still get this stupid memory address. So how do I fix that? What I want is when I print the dog, I want him to say, hi, my name is, and then tell me his name. So the way that I do that is there is a magical method that is always here called Tostring. You inherited it from the object above you, which we'll deal with all of that when we talk about inheritance, but I just need you to get out of this right now that every object in the world has a method called Tostring. What it does right now is it prints out the name of the object and its memory address. If you wanted to do something other than that, which you do, then you're going to need to change the definition of Tostring. And the way that you do that is you override Tostring. So we're going to type the word override with a capital O, and then we're going to say public string Tostring, and we're going to return a string. All right, so now when I run this method or this object, just because I overrode Tostring, all of a sudden, instead of it printing out dog and some random memory address, it's going to print out I'm a string, because that's what I told it to do. That's obviously not very useful. I think what I would like my dog to say is, hi, I'm a dog, and my name is plus name, which is the variable that I have here in my class called name, and therefore when I run this, I'm getting, hi, I'm a dog, and my name is Fluffy. Where is that coming from? In my main method, I am simply doing system.out.println, my dog. All right, so I'm going to come over to C#, and I'm going to do that same exact example because it is mostly the same, but the syntax is just a little bit different. So C# override goodness example. All right, and so we're going to have pretty much the same thing for the dog, so I'm just going to copy that and bring it over. That's all going to be mostly good syntax-wise. I'll show you which parts change in that when I get there. So here we are, and in C# I can put them all in the same file, so I'm just going to do that here. All right, so syntax-wise, that's fine, no problems there. This is the part that's different. So in C#, instead of doing @override, I'm simply going to put the word override in here, so it's going to be public override string, and then in this case it is toString, and string is lowercase in C#. So it is capital T, lowercase o, capital string. In Java, it was lowercase t, capital S. All right? And then down in my main method, I'm just going to do all the same things that I did in the main method over in Java, just so that you have an equivalent example. Nothing wild and crazy there. All right. And I'm going to print out my dog. All right, we're going to run this, and unless I did something stupid, which I usually do, we should see, hi, I'm a dog and my name is Fluffy. All right, so dog.x is never assigned, which that's fine, but there we go. I'm a dog, my name is Fluffy. So that's the equivalent code. So to review, in this lecture, we have talked about overload and override. I will be honest with you, this is going to be on a quiz, it's going to be on a test, it's going to be in every interview that you ever go to where they ask you coding questions, because it is one of the most common things for people to forget. The difference is, in an overload, we have the same method with different parameters. In an override, we are taking a method that has the same parameters and we are changing its definition. You typically do overrides through inheritance, which is not something we've yet talked about, but you're going to see it coming up in the next couple of classes. Overriding is done to change something that you inherited. You inherit a method called toString, and we are changing that method right now. All right, so I hope that clears up the difference between overload and override, and you guys have a wonderful day.